Now we can access the images again, but this time we are using the container SAS token. If we comment this code out, and let me comment out the signature as well. Let's save this, restart the application, and you will notice that images are no longer accessible. So perfect, you can see how we can generate SAS token at either blob level or even at the container level, and everything is working for private container. Now that is not the only way. You can also create SAS token at the account level. You can do that from .NET as we have seen with container and blob, but you can also do that from Azure directly. So if we go back to our storage account, and if we scroll down, we have the shared access signature. I am at the storage account level right now. Let's click the shared access signature, and we have allowed services. What are the resource type? Service, container, object. You can modify things as you want. We will keep everything as the default right now, but again you can see you can toggle with permissions and much more. We have the start and expiry time for about 8 hours, and that looks good. Let me create the SAS and generate connection string. If we scroll down, you will notice here we have the SAS token as well as connection string. You can append the SAS token with all the requests, or you can directly copy the connection string. Let's go back to our application, stop the application, and the connection string for our storage account is inside appsettings.json. Let me comment out this one, and I'll create a new connection here. Make sure you do not make any spelling mistake in the key name. It should be block connection, and let me paste the new connection string that we copied. With this change, let's run the application one more time. This time we are changing the default connection, so that will be used and the images are again accessible. This will only work for 8 hours because that is what we have for the expiry time. In this video, you saw how we can use the shared access signature at account level directly using the connection string. With this, our application for blob storage is working as expected. I will comment out the connection string that we changed, and if we go to blob service, I will just generate the token at container level, and we will add the signature one more time. So with this, our application looks good and everything is working as expected with Azure Blob Storage. Azure Functions enables us to rapidly build, test, and deploy our code in a serverless environment. Azure Function is a serverless concept of cloud-native design that allows a piece of code to be deployed, executed, without any need of server infrastructure, web server, or any configuration. So that is a very powerful service that you can use under certain situations. So let's start off by learning a bit more about what exactly Azure Function is. The first thing that you can see is it is function as a service. So basically you will be deploying your code and that will automatically be executed. Azure Function is ideally a combination of code and events. Code basically refers to the function that responds to an event. Azure Functions also support multiple programming languages, but the one that we will focus on is C# in this course. Now, as I said before, that Azure Function is combination of code and events. Code is something that you will write based on an event that is fired. So let's see what are the different types of events in Azure Function. Events are also called as triggers with Azure Function. So when a trigger is fired, at that point, whatever code you have will be executed. The first type of trigger is a timer trigger. Let's say you want to implement some functionality every end of the day, or even you have some functionality that you want to run every hour. So you will set a timer trigger that will be executed every hour. So you will set a timer trigger Based on that, it will be executed every hour. The next trigger that we have is a message trigger. It basically means that let's say you have Azure Service Bus or Azure Queue. As soon as a new message is received in the Azure queue, you want to execute some function. So at that point, the message bus or queue will act as a trigger point for your function. Next, we have HTTP request. For this Azure function, you will get a URL. As soon as that URL is called with the HTTP verb like get, post, whatever type you want, at that point the function will be executed. These are the three basic triggers, but we have many more triggers. Like let's say you want to execute some function when a new image is uploaded on Azure Blob or you receive an email. You can configure all of the trigger points and you can write the custom code on what it should do when the trigger is invoked. Now that we have a brief overview of what Azure Functions are, before we take a deep dive in them, let's see the advantages Azure Function brings to the table. Let's walk through some of the benefits of Azure Function. Azure Functions are easy to write and deploy. You do not have to worry about creating a server or managing that server. All of those things will be done by Azure Function. You just need to write your code and deploy that. Because of that, Azure Functions are lightweight and serverless. Azure Functions are also fast to execute because there is no large application, startup time, initialization, or anything else to load our Azure function. Azure function is executed when an event is fired. Because of that, Azure functions are compute on demand and they are scalable. We have certain limit with the consumption plan of Azure function that it cannot execute 10 minutes of execution. But if some of your Azure functions are taking long, you can always go for a premium Azure function. So when the demand of an execution increases, more resources are allocated automatically to the service, and when the request falls off, all the extra resources are dropped automatically. So we do not have to worry about any infrastructure or maintenance. Azure Functions also uses the industry standard so they can communicate with other APIs and libraries. Azure Functions also support multiple programming languages like F#, C#, Java, JavaScript, TypeScript, and Python. In this course, we will be focusing on C#. Lastly, Azure Functions are cost-effective. With an Azure subscription, as of now, there are 4,000 free execution of Azure Function. That should be sufficient for our course, but even if you have to go with production application, Azure Functions are super cheap and you do not have to worry about any server maintenance. So you can see there are lots of advantages of Azure Function. But as we proceed with the course and we build Azure Functions, you will see how powerful Azure Functions really are. So let's get started and create our Azure function. Now we need to work on Azure function, but for that we will have to do some setup so that we can process functions and see how everything comes together. So before we make any changes to our portal, we will be using the same application that we were using before. Now if you are getting started directly with Azure Functions, do not worry. We won't be using the old application, we will be creating a new application inside the same solution. So it is basically starting fresh. We will create a new project here and we will be adding an ASP.NET Core web application with MVC. Let me add that and I will call this Azure Function Tangy Web. Let's do the next here. We will be using .NET 6. Authentication will be none here, but we will enable the Razor runtime compilation. Let's create our project. Since we have multiple projects, it is always good to organize them. So let me add a new virtual folder here. The first one we will call Azure Blob example, and we will move our previous project inside there that we will not be using. Inside the solution, let me add a new folder, and this will be for Azure Function example. We will move our function Tangy inside that folder. Perfect. Looks much organized. Inside our project, we just have to create one page. So for that, we first have to create a model that we will be using in our Azure function. This will be a pretty simple model. What we want to do is we want anyone who wants to apply to be a salesperson come to our website and submit a form. So inside our models, we will create a new class, and I will call this sales request. We will be adding few properties in this model. So right here, let me paste 5 properties. We have ID, name, email, phone number, and status. The ID I'm using is not an identity property, it is rather a string. So we will generate a GUID ID for all of the sales requests. This looks good for our model. Let's continue from the next video. Once we have added our model, it makes sense to utilize that model and display to get all the details from the user. So inside our controller, we have the home controller. Let's work on the index action method. We are directly returning back the view, so let's modify the view for our index, and we will be using our model to get all the details from the user. So basically, there will just be few input fields. For the styling and CSS for the views, I have provided snippets. So if you go on snippets, code, we are in section 4, we have the index view. Let me open that up. You can see the model here is sales request. Let me copy everything here and paste it for the index page. We have the model, which is sales request. We have a form with ENC type of multi-part form data. We are retrieving name, email, phone number, and we are also asking them to upload their resume. We have a submit button, and this looks good. With this change, let me change the startup project to our new project that we added. So we will set that as a startup project, and we will make sure to run this on IIS Express. That way, we will get a localhost URL rather than port 5000. So we will get a new generated port, which we can use later on. And perfect. You can see our home page looks good. We are asking them for name, email. We are asking them for name, email, phone number, and they can upload a resume if they want and hit the apply button. Right now, when you click the apply button, nothing happens. We need to add some code there. The processing for when someone applies here, everything will be done inside Azure Function. So this time we won't be working with the code behind file. All we have to do is retrieve the details here and post the result to an Azure function, and then we will process that result. So let's get started with that from the next video. Before we take a dive into learning Azure Functions and making some complex functions from Visual Studio, let me quickly show you that we can also create Azure Functions directly inside the portal.azure.com. So right here, we can search for function, and we have the function app. We will create a new function app, and we have to populate few details. The first thing here is the resource group. You can create a new resource group. I have 2 groups right here. I will push all of them inside the Azure Learning Resource Group. Then we will have to give a name to our function app. I will call that Tangy Web Func. And you can see on top of that it appends azurewebsites.net. Next, when we are publishing to be wanted inside a Docker container or a code, we will go with the code here, and we will have to select the runtime stack. You can see there are multiple languages that are available with Azure Function, and they are adding more as we speak. We will go with the .NET, and that's what we will be using. Now right now the version that is supported is 3.1, but this will change in future for sure. We have the region as Central US, and that looks good. Next thing that is important here is the hosting. When we are working with Azure Function, we need a storage account. You can create a new storage account, or you can use an existing storage account. For this demo purpose, let me go with the new storage account that it is creating. The next option is the operating system. We can keep that as Windows. Next, let's talk about what plan we should select. If you expand this, you can see there are multiple plans that are available. Consumption plan is the basic plan in which you pay for the amount you consume. So you only pay when your functions are running, and this is the default hosting plan. Consumption plans scales automatically. You will select the premium plan if your Azure function runs continuously or almost continuously. This plan is useful if you require more CPU or memory options than what is available in the consumption plan. So as you can see, this is a premium plan and it will come with a higher price as well. Last that we have is the app service plan, which is like a dedicated plan. If you select this plan, you will get existing virtual machines that are already running other app service instance. You will have to provide a custom image on which you will run the Azure functions. In dedicated plan, you pay same for the function apps in a service app plan as you would for any other service app resources like a web app. It will have its own dedicated app service, so it's basically like creating an app service plan. For this course, we will select the consumption plan. Inside the consumption plan, as of now, you are given 1 million free requests and about 400,000 GBs of resource consumption per month if you are in pay-as-you-go subscription. That is way more than what we will require in this course. So we won't have to pay anything for our function app. Next, we have the monitoring tab where we will have the application insights. You can create a new application insights and you can monitor all the details. We will select no for now and we will continue to tags if you want to give your function some tags. Next, we have the review plus create where we will have the summary of everything before we create our function app. Once it completes the validation, we will hit the create button to create our function app. It validates everything and then it deploys our function app. And once the deployment is complete, you will see a button that will take you directly to the resource. You can click here or you can go to the home page. Inside the function app, you will see a new record. Let me refresh this. And it takes a while, but you see the Tangy web function. If you select there, it will take us to our Azure function. Let's continue exploring what we have here from the next video. We created our Azure function app in the last video. Before we explore this, you can see we have a resource group Azure Learning associated with our function app. Let me click on that resource group and we will see all of the resources that were created. The Azure.NET Mastery is the resource that is not created with Azure Function. This is a storage account that I created for the Blob storage, so ignore that one. The most important one here is the function app itself. Previously, the type of function app was app service, but now they have changed that to more meaningful, which is the function app. Next is the app service plan itself, which is consumption hosting plan, which governs the billing for our function app. And finally, you see the storage account that is associated with our function app. Now, if we also enabled application insights, there will be one more entity here of type application insights. We did not enable that, so we only have 3 resources with our function app. Now that being said, let's navigate back to our function app. On the left hand side here, you see there are some of the tags associated with the settings and other entities of our function app. We have monitoring, we have APIs, development tool, app service, settings for the configurations, and we have the functions, deployments, and overview. The main thing that we will be working on is functions because that is what we will be creating inside our function app project. So if we select functions, by default there are no functions that are available. We can create a new function. So let's hit the create button and it will open up a window where we can select the predefined templates for our function. You can see the development environment. We are right now working on develop in Portal, but later on we'll be working inside Visual Studio. This is a great way to get started. We have lots of predefined templates that are available, and these are most commonly used as well. HTTP triggers or timer triggers are one of the most common triggers. As the name suggests, the HTTP trigger will be invoked when an HTTP request is received. It does not matter what is the HTTP type, you can define that inside the function. Next, we have timer trigger. This is a trigger that will be invoked at every time interval that you want. It could be 1 minute, it could be 5 minutes, it could be 5 days. For the first function, we will create an HTTP trigger. Once we select the HTTP trigger, if we scroll down, we can give our function a name. We will go with the default name, which is HTTP trigger 1, and let's create that. It navigates us to the HTTP trigger 1. This will create our function, and then we have code plus test in this tab here. This will create an in-browser code editing experience, and we can see all the code in our Azure function. You can see the content here is inside run.csx file, which is the main file which contains the code of the function. In-browser functions are helpful if you want to quickly edit some details or you want to just see how things work. If you want to create a full-fledged functions, I prefer using Visual Studio. Here you can notice that we have a static run method which takes HTTP request and iLogger in the parameter. It also returns a task of iAction result. The template has also populated the body of our function, and you can see it is looking for a name parameter. It tries to find that inside the query string and also inside the request body. It will check to find that name in any of those two properties, and once it finds that, based on that it creates a response message. If the name is null or empty, it triggers the first one, else it displays hello with the name and HTTP trigger executed successfully. Code-wise, it is pretty simple. Since we created an HTTP trigger, we have an HTTP request that we receive in the parameter. We can do whatever we want with that request, and we can return back if we want to. So this is similar to a function inside a .NET application, but here we are doing everything in cloud inside Azure Function. Now that being said, how do we test this? Let's take a look at that in the next video. In this video, let's test the function that we created in our Azure portal. In order to do that, we will click the Get Azure function, and it will display the URL that we will use to call our function. As you can see here, the domain name is based on the function app name, which is Tangy Web App, and then we have azurewebsites.net. Let me copy this to clipboard and paste it in another window. Right here you can see we have API followed by the name of Azure function, which is HTTP trigger1, and then we have a code right here. The value of this code is a secret key that is needed in order to call this function, and that is present because the default security option is function. If we change that to anonymous, then this will not be required. We will take a look at that in the later videos. Now if you want, you can press enter here and you can see the result directly. You can see this HTTP trigger function executed successfully. Pass a name in the query string, and that is because we did not pass any name, and we get the first response right here because name is null or empty. That is one way to test Azure function. But inside our Azure portal, we have the Test and Run tab where we can do the testing directly here. We will have to select an HTTP method. This function supports both GET as well as POST request, so any one of them should work. You can see inside the body, we can pass the name parameter, and let's try to run this. This time you see a different response. It says hello Azure, that's the name that we gave, and this HTTP triggered executed successfully. If we go to our input and change the parameter from name to something else and run this, you will see the default response that we saw inside the browser. And great, you can see how easy it is to test our Azure function. Also inside the logs here, if you examine, it will display the logging that we had right here inside our Azure function. So with this, we have seen our first Azure function in action, and what we are doing here, let me close this as well as stop the function, clear this out, and let me minimize that. So we can see how easy it was to test and execute our Azure function that we created in Portal. Now we know how to invoke our function, but let me walk you through some more details here. The first one is if you examine here, there are multiple files. There is a README file and there is a function.json. This is the basic file where we will configure the settings for our function. Like you can see, the auth level is function. What that basically means that a secret code is needed to execute this function. If we go back to the URL, that is the code that we have right here. If I cut this code and try to trigger the function, you will see it won't work. It does not find it. It will only trigger if that code is present. So once we paste that and run it again, it is executed successfully, and that is because of the authentication level. You can set the authentication level to anonymous, and then you won't require the code anymore. Now where is this key that we are using right here? That is present if you go to the function keys. You will have that key values by default right here. So you can delete this if you want, or you can create a new function key if you want. Next we have the monitor tab, and here we do not have any application insights. So if you want, you can configure that right here, or when you are creating the function, you can just add the application insights there as well. Let me switch back to the code and let's go to function.json. So in the bindings, the first one we saw is the function, which requires the key. After that, the type of the function is an HTTP trigger, and you can see in the methods, we accept both GET as well as POST. If you remove this to be only GET and then you post to that URL, you will not get a response anymore. Also, the name of the incoming parameter is REQ, and that is what we are using inside run.csx right here. Let's go back to function.json, and then we have the output parameters right here. Now do not worry about modifying this file because most of the times you do not have to work with this file. It will automatically be configured based on what you have inside the run.csx. So your main focus will be working on run.csx. But it is useful to know about function.json file as it defines each function in your function app and what are its trigger and bindings. Azure Portal actually has a custom view that makes it very easy to change the settings defined in function.json. For that, let me go to the integration tab. And right here, you can see the trigger, the function itself, and what is the output. If you click on the trigger here, you will notice that you can change the authorization level, the HTTP methods, and the name of the input parameter. So that would make things much easier to edit. You can also edit the output parameters. Looks good. So with this, we have a great overview of the function that we added. I also want to show you one more thing. Let me go back to the function app and create one more Azure function. We will keep it the same HTTP trigger. The name will be default HTTP trigger 2. Authorization level, we will keep that as function. and let's create that. Perfect, it has been created. Now the details will be similar to the other function that we have, but if we click on resource group directly here, and we have the storage account that was created for Azure Function. Let me open that up. Here we have a storage explorer in preview. Once you open the storage group, we have the blob containers. That will just have the JSON file with the secrets right here for both the function that you can see. But the main question is, where is the actual code that is being executed for Azure Function? That is inside file shares. We have the Tangy web function here, and inside the site, you will notice in www we have the complete code. We have HTTP trigger 1 with all the 3 files, HTTP trigger 2 with all the files, and then host.json. Now you will not be required to manage code directly here, but it is always good to know that where the actual code relies when you publish things to Azure. So with this, we have seen how Azure Functions can be created in Azure Portal and how we can manage everything from the Azure Portal. Ideally, Azure Functions are not created inside Azure Portal because functions can be lengthy in code, and writing all of that code here is not that developer friendly. So it's time to learn the right way of creating Azure Functions. That will be using Code Editor, which we will use Visual Studio for this time. So let me go back to the resource group and let me delete all the resources that are related to the function app. I will select the 3 resources that are related to the function app and do not click the delete resource group. That will delete all of the resources. We just want to delete the 3 resources that we selected. So we will hit delete button and we will type yes, hit the delete. Perfect. So with this, we have cleaned up the Azure functions that we created. You will see in the recent resource here, but this is actually deleted. It just does not refresh. With that in place, let's work on calling Azure Functions from Visual Studio in the next video. Now it's time to switch back to our application. So let me minimize this and let me run the application that we have with the new project. When we hit the apply button here, we want to call an Azure function. So the first thing that we have to do is we need to create an Azure function inside Visual Studio. Let me close the project here, and that will be a different project by itself. It will not be inside the same web project. So inside the folder Azure Functions example, let me add a new project, and here we will search for Azure Functions. You can see the project is available for me. If this project is not available, you will have to go to the Visual Studio installer, and there you will have to click the Modify button. Here you have to make sure that Azure Development is selected and installed. If that is not installed, then you will not see Azure Functions when you hit Create New Project. We will select the Azure Functions and we will hit the Next button. Let me give our function name Azure Tangy Func, and let's create that. Now, as we saw in the portal that when we create Azure Function, we will need a storage account. So you can either create a new storage account or you can use the storage emulator that comes with Visual Studio. For initial testing, we will just use the storage emulator so you can get a feel of that. The first function that we will create will be an HTTP trigger, and the authorization level, we will keep that as function. With that, let me create. With Visual Studio 2022, there is a bug in the UI, because of which right now you see it displays Azure Tangy Func here, and it is messing things up. Do not worry, once the function is created, if it gives you some weird errors, those all will be fixed with the final release of Visual Studio 2022. If you see any errors when you add Azure Function, just restart Visual Studio and everything will be aligned. So once you create the Azure Function, let's continue in the next video.